let's quickly recall that linear model that we had. We had this Lij equal to alpha I plus beta Wij plus the error. Now I want to specify this using our sentence. Let's see how we do that. I will write it here. Fit equal to lm, I will have length, no problem with that. I will fill up the rest and put all lab here. Now what do I want to put here? I do not have any intercept term, so I will put a -1 later. The very first term that I have in here is alpha I. I stands for lab, so I will write lab. Then the next term that I have is based on the weight, so I will just write weight. So I simply write length is lab plus weight, which in a sense reflects very nicely this box diagram. Length is the added effect of weight and lab. So this form is very well suited for the box diagram. If you have the black box diagram, you can immediately write down this form, lab plus weight. But if you want to compare it with this mathematical form, it is slightly more involved. Alpha I becomes lab, and this beta thing, that becomes the weight. Okay, so let's just try it out. And let's see what is inside fit. Oh, I have made a mistake. Because if I do this, then it will have an intercept term. Let's just take a look at it. Yes, it has added an intercept term and lab 2. I do not want that. So you might be wondering what happened to lab 1, but let's not worry about that. For the time being, I will just subtract that 1, saying that do not add the intercept term. Now let's take a look at fit, and you will see whatever you wanted to see. You have got lab 1 coefficient that according to our parlance was alpha 1. So alpha 1 hat is 3.276. Alpha 2 hat, that is 5.173, and alpha and beta hat is 2.013. So this is how you get all these things. Now you might be wondering what happened there when I put that intercept term wrongly. Somehow magically it reported only lab 2 and not lab 1. That is indeed somewhat like a magic, and we shall take a look at that magic later. But for the time being, let's quickly see what is the design matrix that it is using. Model.matrix fit. Ignore all those attributes, ATTR. You have 11111 for the first 6. So here you have got alpha 1, alpha 1, alpha 1, no alpha 2, and then the W1Js, W11, W12 up to W16. The remaining 6 entries, make it larger, the remaining 5 entries, they come from lab 2. They do not have any contribution from alpha 1, they have only contribution from alpha 2, and of course we have W21, W22 up to W25. So the model matrix is exactly as we expected it to be. So it constructed the model matrix for us. That is a very important reason why we should use the LM function. We just specify the model, it creates the design matrix, or the model matrix as it calls, for us. Okay, so that's all for this session.